In this lab, we will continue with step 7 of an Alpine Faults data analysis. We look at output metrics, that is composite risk score. Let's create a composite metric that combines shaking, which is given by MMI column, and liquefaction susceptibility given by LQ underscore SUS column. So this is the kind of composite metric that we want to produce, where the colors are showing the risk score, and um, the x-axis values are less than or equal to 6, 7, 8, greater than or equal to 9, and then the y-axis values are 1, 2, 3 in the middle, and 4, 5. So let's look at the buildings data frame. So buildings data frame. So if I do that, insert a cell above, and let's display buildings. So you see we have LQ underscore SUS column, and we have MMI column. MMI column shows the shaking intensity of the earthquake in Alpine Faults line, and the risk score is the risk measured from 1 to 5. Now, so what we want to do is that we want to measure the risk score. Okay, so buildings, because I had already run these functions, that's why we have risk score already added, but it's created from this function here. Composite risk assumed based on the figure above. Composite score list equal empty array. For I, rows in buildings dot iter rows, open and close bracket, and the columns. I represents the row index, and rows represent the data row. So let LQ equal rows LQ underscore source. So we're looking at the liquefaction susceptibility, and we let it equal to LQ for each of the rows, and the shaking intensity, the earthquake shaking intensity, we let it equal to MMI. Then top row of risk matrix. So risk matrix, we have a matrix and the top row. For the top row, the very top row will contain LQ more than or equal to 5. So if LQ is greater than or equal to 5, and if MMI greater than or equal to 9, then risk equal 5. If MMI greater than or equal to 7, then risk equal 4. Else, column, risk equal 3. The middle row of risk matrix, if LQ equal 3, colon, if MMI greater than or equal to 9, colon, risk equal 4, if MMI greater than or equal to 7, colon, risk equal 3, else, colon, risk equal 2. Bottom row of risk matrix, else, colon, if MMI greater than or equal to 9, risk equal 3, if MMI greater than or equal to 7, risk equal 2, else risk equal 1. Composite score list dot append risk. So composite score list will contain the value of the risk for each of the data rows. Buildings risk score. Now we are creating a new column called risk score in the buildings data frame, and we let it equal to composite score list. And we display buildings data frame here. So we have a risk score column created with the values. Then we check the risk score value counts. So risk score equal 3 is 14,094 values, and risk score 1, 9,510 values are risk score 1. 9,055 values are with risk score 2. 8,961 values are with risk score 4. 5,488 values are with risk score 5. Visualize risk score in buildings data frame. So background underscore map, let it equal to South Island dot plot bracket color equal gray. Buildings dot plot bracket AX equal background map, comma, column equal risk score, comma, legend equal true. So the background map will be plotted, and on top of it, the risk score will be showing. And the colors range from blue to yellow. Blue is the lowest risk score value, and yellow is the highest risk score value. Create a data frame of subset. So let temp equal buildings, double bracket, MMI, comma, LQ underscore SUS value, comma, risk score. And that will create a data frame. I append this data frame with the columns MMI, LQ underscore SUS, risk underscore score. Reassign with conditions for MMI. For I rows in temp it rows, for each of the rows in this temp data frame, and I represents the index of that row. If MMI less than or equal to 6, a temp dot location bracket I, comma, MMI bracket equal, we put this string value less than or equal to 6. Elif rows MMI equal to 8 or MMI equal to 7 colon temp dot location square bracket I comma MMI equal string 7 comma 8. Elif rows bracket MMI greater than or equal to 9 colon temp dot location square bracket I comma MMI equal string greater than or equal to 9, and printing temp gives this. Reassign conditions for LQ underscore sus. So in this column MMI, we see that the values are replaced by the string values greater than or equal to 9, 7, 8, and less than or equal to 6. Reassign conditions for LQ underscore sus. For I rows in temp dot it rows, open and close bracket, and the colon. So each of the rows in the temp data frame. If LQ underscore sus equal 4 or LQ underscore sus equal 5, then temp dot location square bracket I comma LQ underscore sus equal string 4 comma 5. Elif LQ underscore sus equal 3 colon temp dot location I comma LQ underscore sus equal string 3. Elif LQ sus equal 1 or LQ sus equal 2 colon temp dot location, open square bracket, I comma LQ underscore source, close square bracket, equals string 1 comma 2. So when we display the temp data frame, we get this. So where the LQ source values are replaced by 4 comma 5, 3 and 1 comma 2, and the NaN values, they remain NaN. Now count the values. So temp equal temp dot value counts, open and close bracket. So this will not count NA. So temp, when we print that, so we get these values. Now we'll reset the index of this temp data frame and we let it equal to temp1. So this forms a data frame, pandas data frame. So in a table form, in a table form, so if MMI is less than or equal to 6, if LQ sus less than equal 4 or 5, then the risk score is 3 and the count is 11,335. So yeah, so if MMI is greater than or equal to 9 and LQ sus equal 3, then risk score equal 4 and the count is 7,837. If MMI less than or equal to 6, LQ underscore sus equal 3, risk score equal 2, and the count is 6,950. If MMI is greater than or equal to 9, LQ underscore sus equal 4, 5, risk score is 5, and count is 5,488. If MMI is less than or equal to 6, LQ underscore sus is 1, 2, and risk score is equal to 1. The count is 4,165. If MMI is 7, 8, LQ sus is 4 or 5, then the risk level is 4 and the count is 1,124. If the MMI value is greater than or equal to 9, LQ underscore sus equal 1 or 2, then risk level is 3 and the count is 925. If MMI equals 7 or 8, LQ underscore sus equal 3, then risk score equal 3 and count is 202. If MMI equals 7 or 8, LQ underscore sus equal 1, 2, then the risk score is 2 and the count is 195. Drop a column, temp1 dot drop open bracket count. So we drop this column count, x is equal 1, comma in place equal true, and that drops the count column. Then we import Seaborn as SNS and we plot category matrix. So by passing the command G1 equal SNS dot dis plot, open bracket temp1, comma x equal MMI, comma y equal LQ underscore sus, comma hue equal risk score. So hue is the colors. Bins equal 10, palette equal bright. So we could avoid this bins equal 10. We don't need this. So we get this. Okay. So when the MMI is less than or equal to 6, LQ sus equal 1 or 2, then the risk level is 1. Let's check in this function that we did here. So MMI, so LQ is 1 or 2, MMI is greater than or equal to 6. Then the risk is 1. and so on. So the green ones, let's check this red one in the middle. If MMI is greater than or equal to 9 and the LQ SUS equal 3, then the risk level is red, which is 4. Risk level equal 4. Let's check that. So in this function here, MMI is greater than, so LQ value was 3. Yeah. If MMI is greater than or equal to 9, then risk equal 4.